Look at the following equation. Imagine you had to do equations like this or worse all the time. To make calculations like this one easier, we can write these numbers in scientific notation. Scientific notation has three parts. The first is the coefficient, the second is the base, and the third is the exponent. The coefficient has to be between 1 and 10, which means that we need to have only one non-zero digit in front of the decimal point. Let's start with scientific notation for really big numbers. For example, how do we write this number here in scientific notation? Step 1, move the decimal point from wherever it is originally until there's only one non-zero digit in front of it. We're moving it 19 times and we're moving it to the left. The number of times we move the decimal point becomes the power of 10. We had to move this decimal point over 19 places, so our power is going to be 19. So this big, huge number, when written in scientific notation, becomes 1.2957 times 10 to the 19. Now, in your notes, you'll see a few example problems. Pause the video and try them yourself, and then come back when you're finished, and we'll go through them. Example: write the number 75,800 in scientific notation. Step 1. First, you're going to move the decimal so that there's only one non-zero digit between 0 and 9 in front of it. So here we're going to move the decimal point to the left 4 times. Step 2, count the number of times you move the decimal place. This becomes the power of 10. So for this example, we moved the decimal place 4 times, so our answer is 7.58 times 10 to the 4th. Here's another example. Write the number 8,351,296.23 in scientific notation. This time, the decimal is not at the end of the number, it's in the middle, but we can do the same thing. First thing, we're going to move the decimal to the left. We'll have to move it 6 times. And since we moved the decimal point 6 times, our answer is 8.3512963 times 10 to the 6th. Here's another example. Write the number negative 23 million in scientific notation. First thing we're going to do is move the decimal point to the left 7 times. Our answer is negative 2.3 times 10 to the 7th. We need to remember to keep the negative. Okay, so how do we do scientific notation for really small numbers? For decimals, one thing you should know that is if the number is less than 1, the power we're going to end up with is going to be negative. So step 1, move the decimal point to the right so that there is one non-zero digit in front of the decimal point. For this example, we are going to move the decimal point to the right 16 times. Step 2, the number of times we move the decimal point becomes the power. We had to move this decimal point over 16 places, so our power is going to be 16, but since we moved our decimal to the right, the power is negative. So our final number is 9.9 times 10 to the negative 16. Here's another example. What is 0.000216 in scientific notation? Pause the video and try it yourself, then come back when you're done. First, we're going to take the decimal point and we're going to move it to the right 4 times. Our answer is 2.16 times 10 to the negative 4. So, how do you convert scientific notation to standard notation? For our first example, we're going to write negative 2.46 times 10 to the negative 8th in standard notation. The power negative 8 tells us that this number is going to be less than 1. So we need to move the decimal point to the left 8 times. The negative sign in front of the 2 tells us that this is going to be a negative number. So we need to remember to put our negative sign in our answer. Our answer is negative 0.000000246. So we've got 7 zeros in there. Here's another example. Convert 9.6 times 10 to the 7th into standard notation. For really big numbers like this one, we do the same thing. However, we move the decimal to the right. So we are going to move the decimal point 7 times to the right. Our answer is 96 million. Now you should be able to convert numbers from standard form to scientific notation and convert numbers from scientific notation into standard form.